Good morning, guys. Welcome back to another episode here from the Off-Grid Garage in sunny, hot Australia. I want to show you. I have been excused to make false claims here, but look at this. Beautiful winter weather here in Australia. Okay, it is not super hot yet, but we will get the 22, maybe 23 degrees today. Yeah, it looks a bit like a mess in here after last night's installation of the SEPLOS MASON battery pack here. But I had a look this morning again and thought, well, this is really, really well thought through and designed here. It seems so easy, you know, you don't need to think about what to buy, how to design it, how to manufacture it, how to put this all together. This is all done for you already. It is different. It is different to what we have done in the battery shelf here. Absolutely. So in today's video, we want to have a look at the display, what kind of options it gives us here, and also want to connect this one to a computer and deep dive into the BMS and see what we can set up, and probably do some charging and discharging tests here with the battery. But I think it's only charged to about 30%. Hang on, I can tell you exactly actually, because the 4 batteries I've tested they had only 50 ampere hours charge left. So this makes 135, it's 100% divided by 50 times, yeah, that's a 37% state of charge. So they have also sent me this RJ45 to USB adapter. Apparently it's not RJ45, it's just the socket for it, but it is an RS485. And also a 1.5 meter Cat5 network cable. I think you can use any network cable. And this then plugs into one of your RS485 ports, number 1 and number 2. I think you have 2 to daisy chain these devices together. If you have more than one, or if you want to expand over time, you just connect them to each other and they will all listen to the master. And you can set the master slave function here with these dip switches on the BMS directly, and you only have to turn on one device then, and all the other devices will turn on. They all listen to the master. That's how it should be, right? And this USB adapter is just a plug and play. It just plugs in. It doesn't need any drivers or something. It's been recognized by the system in Windows 10 automatically. And I had a bit of trouble finding the software actually for the BMS here. Eventually I found it. It is on the SEPLOS website. So you go to seplos.com. It is not in the BMS section for some reason. It is under other parts. And then you scroll down until you find this USB to RJ. This is the RS485 adapter. You click on it. And there further down in the text, there's a link. Please download the software, application and drivers here. And this brings you to a Google Drive folder, a shared folder. And we can see here is the BMS software download, the driver software, I'm not sure if we need this, the SEPLOS battery monitor upgrading firmware. I really like this one because these BMSs are firmware upgradable. That is an amazing feature I wasn't aware of. We've got the specification data sheet of the BMS and battery packs here, certifications of the SEPLOS devices, I guess. The dip switches, address setup, RS485 and CAN, so a very handy document to have, definitely. And the SEPLOS wiring diagram if you want to wire your BMS differently or individually if you only buy a BMS from SEPLOS. Okay, how do I do this here? Get link, download, there it is. Right click on it and download. Okay, while the other files are downloading, we can have a look at the dip switch settings already, and this is the document you can download. They're not making many words on this one, but it gives you all the information you need. If you have only one device, as we have here, up to 15 of these devices in parallel. That would be very close to 100 kilowatt hours then. Yeah, and you can see if you have only one device, you don't need the dip switches at all. They are all in the off position. And if you have 2 devices, number 1 is your master and number 2 is your slave. And with 3 configurations, number 1 is the master, number 2 is the slave, and number 3 is the slave as well, and so on. Very straightforward programming with the dip switches. And last night when I was cleaning up here a bit, I found this sentence here on the installation guide of the SEPLOS MASON system. It says, after installation, please follow the steps to let the BMS get the real capacity of the battery pack. Fully charge the battery to 100%, suggested charging current 50 amps. Fully discharge the battery pack until the BMS shuts down automatically with 50 amps again, and then charge back to 25 to 50% accordingly. So this is pretty interesting. So we don't need to set a capacity of the battery pack manually. It will do it automatically. It will measure the capacity automatically and set this learned capacity as, well, our usable capacity then. That'll be interesting to see, because I don't think these batteries are balanced yet. So when we fully charge this battery, we potentially, I don't know yet. We will see. Okay, so we have now successfully downloaded the user manual for the smart BMSs. We've got the 100 amp version, and it is a 16-page document. Battery connection, iOS 485 to USB adapter. So here's the picture again. Click this one in. Following the diagram, oh, they've got the pin out here as well of the RJ45. Very interesting if you want to make your own connection. So they're saying if you buy the adapter on the market, make sure the wiring diagram is as follows. Otherwise, the battery monitor cannot be recognized. Okay, if it doesn't work, well, this adapter is $20 or something on the SEPLOS website. You can buy them from AliExpress for $3 or $4. But I mean, if you spend $1,500 on a battery, you know, why wouldn't you spend the $20 as well and get the right adapter? Okay, here are more pictures for installing this software download installation. Double click the .NET framework. Okay, whatever that all means here. Let's extract the battery monitor. Battery monitor exe. I'm starting this one here. Let's see. Ah, there it is. There's our software. Okay. Okay, so I guess we have to choose the COM port. I think it's COM5 in our case. Oh, I haven't connected anything. I just use my own cable to prove you don't need a special cable to connect to the BMS. I don't know how to... Does it matter which RS485 port I use? Some USB that I need drivers, laser make sure before. I guess we just try. So I plug in one end into the adapter and the other one goes into the BMS. I'll choose the 485-1 port. That clicks in, and I guess we have to start up the BMS, pressing the button. Oh no, there's no light or something. Ah, COM1, COM5, connect. Connecting. Timeout. Oh, that's not good. I don't know, it doesn't say in the manual how this works. Nice. I try the other RS485 port. It is definitely COM5. Connect. Connecting. Timeout. Okay, give me a second here. I'll read through the manual and tell you how it works. Okay, I found it. I found it in the manual. So what we have to do is we have to change the baud rate from 9,600 to 19,200 apparently, and then connect via COM5. In my case, there's a different COM port on your computer. Then we click on connect, and it connects to the BMS. We've got the overall voltage here, the amps. We've got all the different cell voltages showing up here, and this is the communication animation down here. And it doesn't matter which port you actually use. I have disconnected the port and plugged it into the 485-1 port, and it's still communicating. So it doesn't really matter which port you are using. So, no warning. Remaining capacity, total capacity 135. We are at 38.5%, which could be actually true. Rated capacity, cycles, nothing. State of charge, 100. Bus voltage, 52. Temperatures. This all seems to work. We've got all the cell voltages here. And I guess down here in these buttons, these are all your other BMSs connected to this BMS, all your slave batteries then, and you just click on one of these slave batteries and then you can see the voltages on this battery pack. Because we have only one pack here, it doesn't really matter at the moment. Okay, so do we have to load the parameters? To manage the parameters, you need to log in as administrator account admin. Upload parameters, that's what we want. Admin. Okay, and then we need to click on upload parameters. And here we go. These are all the numbers and figures which are interesting. Okay, here we go. So if we change the column here a bit wider. Over voltage protection 3.65, nice. Under voltage 2.7, where we can change this later to 2.5 if we want to. Under voltage recovery, high voltage alarm, this is for the whole pack, and so on. This all seems to be very familiar and very straightforward. These are the current limits we can set. What is an compensation point? Ah, it's a compensation point. And these are your function switches. So we can turn off or turn on the temperature sensors. We can turn off charging. We can turn off discharging. Low temperature, under voltage temperature occurring. Oh, there's a lot of parameters in here. Is there like a balance turn on voltage? Voltages are going up to here. Low voltage forbidden charging. That is new. I cannot seem to find any balance parameters. I mean, the BMS has only a balance current of 150 milliamps passive balancing, so that is not great, and that's what I always said, well, why should I buy this BMS? Because we've got the JK-BMS. Here, equalization opening voltage 3.4 volts. Then this is when the balancer kicks in. That is fine with the passive balancer. But there's no deviation to set now, which is fine. It should balance until it's 1 millivolt or even 0 millivolts. Okay, I think we leave all the parameters as they are and change them accordingly when we need to. And then we can say set all. And this pushes all the parameters from the computer back into the BMS then, whatever you have changed. This all seems to be very straightforward here. And I really wonder if we can do some programming with the display here as well. Does it turn off after a while? Yes, it does. Okay, let's have a look at the display as well. Okay, I'm just cleaning up this area here with alcohol because I want to attach this there's a screen protector. Oh wow, there it is. Satisfying. Brand new display. Okay, and now we want to attach this film here. Oh wow, this will be a total nightmare, I think. Okay, let's see how it fits. Oh, yeah. Yeah. Okay. No pressure, huh? That's a one-off sticker. It's a one-off sticker. If I f this one up here, it will be always crooked, and I will always look at it, and you will always mock me. The buttons first. Go over the buttons, then have the display, and oh, I think I did it. And there's another protection film on top of the sticker. It's a sticker protection film, so to speak. There it is. Here it comes. Satisfying. Nice. Look at this professional design. Huh? Look at this. I think this is the main menu here. So you've got the pack voltage, the current, the state of charge, and warnings, nothing. So if we go up, okay, up, down. Yeah, warnings, temperatures, confirm. These are all 4 temperature sensors. That is cool. I like it. Exit. Okay, let's go up. Cell voltages, confirm. Oh, look at this. we can read the cell voltages here on the display. 1 to 4, 5 to 8, 9 to 12, 13 to 16. Perfect. Then exit. What is number 4? Capacity. Confirm. FCC. Is this the nominal capacity? This is not what it learned. RM, this is what we are, and cycle times 0. So I think this is the maximum capacity, what it claims it could be without learning, maybe. And this is the current capacity we are at, and the cycle time is 0. Exit. Okay. Warnings. Over voltage protection, under voltage. Yep, you've got all the warnings here on the display as well. Okay, I think, is there more after 4? No, these are only the parameters we can see here on the display, so it's very straightforward with up and down, confirm, exit, and then it will turn off after a while as well. It's actually useful. 52 volts, we are actually live here. So I'm now going to discharge this 15 kilowatt hour battery over there with the Xia inverter. Our power supply is connected to this inverter. We have set 52.4 volts, 1 amp. Everything is connected. We have these 25mm cables here for the test. And well, let's turn this one on and see what happens. There should be nothing happening. Exactly, well, because this voltage of the power supply is lower than the actual battery voltage. Well, so far so good. I'm increasing the voltage here of the power supply slowly. 2.7 now, 52.8, and we have 1 amp going into the battery now. We are charging with 1 amp. There you go, 1 amp. And this should be the same as the on-screen display. There's a bit of a difference, isn't there? Looks like it. Okay, let's go a bit higher. So this is now 5 amps, 503, and it shows us 495. I'm not sure how precise this is or how precise this is. It is roughly 5 amps. Okay, let's increase this one is delayed here on the display, while the one on screen is fairly quick. I just saw it shows us the voltage difference as well over here on the screen. 5 millivolt we have. Maximum minimum voltage. Cell number 3, cell number 2 at the top here. Here, interesting is that we are pulling 27 amps from the Xia inverter from the battery there. And we are pushing 20 amps into our battery here. So it goes 50 volt from the battery into 240 volts. 240 volts makes 55 volts and 20 amps, and then we charge our 50 volt battery here again. That is like 74% efficiency, so it's not too bad actually. I mean, we are converting twice from DC to AC and from AC to DC again, have all the charging connection losses and everything, and still 75%. Pretty good, I think. It's on 55 ampere hours only of 135. So I guess see you in a couple of hours. But here, this is our capacity meter, and the second one is flashing. Is this flashing because it's charging? If I turn off charging, yeah, it turns off altogether, right? Yeah, so this one only comes on while charging. Maybe while discharging as well, we don't know yet. So while we are charging our battery here, to sum this up, you only need to download the first file here, basically the first folder, 01 SEPLOS BMS software download. This is all you need. Everything is included in this folder. Once you download it, there's the battery monitor installation and operation guide, as well as the software. And you only need to start the battery monitor exe and this will run the software then. And in here you choose your COM port and the baud rate of 19,200. Click on connect, and that's it. You get the real-time data of your battery on the screen. So you don't need any additional drivers or software under Windows 10 with this adapter. So the fourth light is flashing now. Guys, I tell you, these LEDs are so bright, it is not funny anymore. They really burn in your eyes. We are at 76% state of charge, so I guess we are in the last quarter of charging this battery. And we want to have a quick look at our software. So we have a deviation of 14 millivolt right now, but we are only at 77% state of charge, so we are still in the flat area of the curves. Up here it shows us cell number 1 is our highest. No, actually I cannot see that. Now I can see it. So cell number 16 is our highest cell, and cell number 14 is our lowest cell. This is already at 3.4 volts. What are the others? Yeah, 3.4. Well, okay, so number 13, 14, 15 and 16, these were the cells which I have tested. These were the last four. These were the last 4 cells I put in the case. These ones have been capacity tested, so they may not have the same state of charge as all the other ones. Let's see. Okay, this may take another hour until it gets interesting. Okay guys, so here's the problem. The BMS has turned off charging because it thinks the battery is full. We are at 99.8% state of charge. But this is not true. It was only cell number 16 which was peaking at 3.65 volts. The BMS turned off. The recovery voltage for that is 3.6 volts. So everything under 3.6 volts should actually turn on the BMS again. But it doesn't. As you can see, we have a warning here. It says intermittent power supply waiting. Great, right? The BMS is working fine. I can read the display, and you can see we have a 3 millivolt deviation, but I'm completely unable to charge the battery any further. The charge switch is turned off. So no power is going into this battery anymore, but I can discharge it. So here we go, discharging with 5 amps at the moment. 7 amps, all right, whatever. And now the charge switch has turned on. I turn off my load and the charge switch turns off again. So I'm not able to fully charge this battery. There is a certain imbalance because cell number 16 was peaking first and disconnected everything, but I'm not able to let any power into this battery. Okay, let's see. Now it's turned on again. It's intermittent. Must be around 3 amps or something where the threshold is, or 2.5. So that is shit. This is a similar situation we had in the Heltec BMS as well. When the BMS decided to turn off charging, turn off discharging just by itself, because it wants to protect the battery from something, but we don't know what it is. I've checked all the parameters 3 times now. I cannot find anything which prevents charge to go into this battery. So of course I did a Google search. I found something in the do-it-yourself forum. Someone had the exact same problem, and then found out that the battery needs to go under 96% state of charge, or you can go into the parameters and change the capacity, and then the charge switch is enabled again. Well, how shitty is that? The whole software with the whole settings here, this is all very... I would rather have an app on my mobile phone and I can quickly swipe through and get to the parameters quickly. This is all very complicated. I need to start the computer first, load the battery monitor software, log in as administrator, find the parameter, change the parameters, upload the parameters again to the BMS. This all takes a long time and is not very intuitive to operate. I tell you what, there's nothing better than smart BMSs and an app on your mobile phone. So the only thing I can do now is battery rated capacity 135, state of charge 134. Okay, set all. Okay, I turn off my load and there's still no charging switch available. I cannot charge the battery any further. What a freaking nightmare. Okay, let me discharge the battery here for a moment. So I'm not sure. We are discharging with 20 amps. That is very disappointing. And I really wanted to have the battery at 100% state of charge to have a look at the balancing function and how the BMS performs. But, well, we can already see how the BMS performs, right? I don't like it. Okay, let's discharge with 30 amps here. And then we have to wait until this warning goes away, apparently. Okay, let's turn off the load. Nah, see, it turns off the charging switch again. Well, I don't know. Apparently we have to wait until we go under 96% state of charge. So, let's, and now it goes up to 30 again. I'm discharging the battery with constant 30 amps. Yeah, here. 25, 26 amps. But the BMS there shows 16, 12 only. Okay, I would say let's leave it running for a while and see if this makes a difference, what people said in the forums there. Disappointing so far. The BMS, totally disappointing. I hate it. And again, the current goes down to 15 amps only, even we are pulling still 25. And then it goes up to, again. 25.8. This is constant. It's a constant current we are pulling. Now look at this, 17, 18, and then it goes up again to 25. So it shows the correct current. There we go. It goes even too high, 30, 25. Well, this could be again the case because we are using an inverter and we have DC ripple on here, and depending on when the BMS is measuring, it shows different currents, and it does an average of the measurement values it had for the last whatever minute or so, and then I don't know. It's just not good. We are at 96% now. I turn off the load. Okay, turning off the load. And we still cannot charge anything into the... Okay, keep discharging. Okay, we are at exactly 96%. So the guys in the forums were right. And now charging is enabled again. So we can recharge the battery now and can see what actually happened. Okay, non-warning. Amazing. Okay, let's recharge the battery to 100% again and see what happens. Watch cell number 16. This was the one which caused the trouble. This is 21 amps coming from the power supply. This is all I can charge into this 60 volt battery. So this is like 1.2 kilowatts or something. Does it say it somewhere here? No, it doesn't. So there's also no indication if the balancer actually is turned on or so. There's nothing in the system status, there's nothing on the battery itself that the balancer is on. So I don't even know if it's balancing at all. It is getting cold again. Let's have a look what's going on. So cell number 16 is our high cell again, 3.45 almost. And cell number 2 is the lowest one. We are still charging with 55.2 volts on the power supply, which is then 3.45 per cell if they would be all balanced. But we can already see cell number 16 here is a runner. So you can also see it's flashing. So I'm not sure if this means it's getting balanced or so. I don't know. There's no further information in the manual or anywhere else. Now it's getting high. It's turning orange. And now we've got the same warning again here. But we are still charging with 20 amps. And the BMS will turn off. I lower the current now. I lower the current to 3 amps only. And let's see if the voltage actually goes down. Yeah, it goes down. Okay, cool. See, we've got 134 millivolt deviation now in the battery. but it claims we are at 98.3% state of charge. So at the moment we only have a high voltage alarm of one of the cells, and this is so annoying. Okay, the high voltage alarm 3.5, and it clears at 3.4 again. And this is exactly what we can see here now. We still got the alarm running, but we won't reach the 3.4 anymore because I will start charging again now. It doesn't show any charge current here, 0. But I'm sure. So we are charging with 3 amps, same as the power supply says, but here 0, nothing. What about the display? Shows 3 amps. So why the heck is this happening? Is this because the stupid settings page is still open here? Ah, okay. Oh wow. This software needs a lot of attention. Okay, going back to 10 amps, 3.5 volts, but all the other cells are under 3.4. So this is really a runner here. Okay, let's see when the BMS turns off now at 3.65. I just want to see this again. What exactly happens here? Okay, point. Okay, we are at 3.6 volts, 3.61, 3.63, 6.4, and 6.5. Bang! Over voltage protection, turns off the charger. That is all good. Leaves the discharging on. Perfect. So this is all working perfectly fine. At 3.55 it turns it back on. That's how the settings are. Okay, let's see, 3.55 here. Down here we can see the cell voltage. It actually goes down fairly quickly. I wonder if the balancer is working on it or something, I don't know. But apparently it's only 150 milliamps or so. But the moment the charge switch is off, so we cannot charge the battery anymore, and it also states state of charge is 100%. As soon as the cell hits 3.65, yeah, and now we've got the same message again, intermittent power supply waiting, and the charge switch is off. So the BMS decides you're not allowed to charge this battery again until we hit 96% state of charge. I think this is totally wrong. It should not be up to the BMS to decide if I want to charge my battery or not, unless it is an emergency and one of the cells goes out of the specs. Yeah, over 3.65 or under 2.5, or we have a high current situation, a high temperature, any kind of that, the BMS should turn off and should stay off, but not because of an intermittent power supply waiting message, a warning. This is exactly the same what the Heltec BMS does as well. Okay guys, I would say I have a play with this software and see what I can find out. I don't know, so far I'm not a big fan of this software and of the BMS. Not at all. You know, when the lights come on, this has nothing to do with Christmas. I'm manually discharging cell number 16 here with the light bulbs to prevent the BMS from turning off again. I need to wait until the other cells are catching up. So I connected cell number 16 to our light bulbs and hope for the best. The same shit happens to the same guy again. Manually balancing a battery pack because the internal balancer is not capable of doing it. What a shit show. So after mucking around for 40 minutes to balance these battery packs, I went away from the light bulbs back to the active balancer here. Yeah, I probably have to clean up these cables here a bit and So I will not leave this active balancer inside the battery permanently. I will disconnect it, but leave the cables connected. So in case of a maintenance, I can just take off the lid of the battery, connect the balancer, and everything will be fine. Because I have my honest doubts that the SEPLOS BMS is able to balance these batteries here. Even once they are balanced, you know, I'm not fully charging my battery every day. It could take weeks or months until the next full charge, and then they are so out of whack. The internal passive balancer has no chance to balance this battery pack. Nothing. So hence the active balancer now, and this will sort it out because we know that from other batteries. So let's check back in tomorrow and see what the battery does. I hope you have a wonderful good night and see you tomorrow afternoon. Yeah, it is now day number 3 of testing the SEPLOS MASON 6.9 system here. And I have now fully charged all the battery cells individually because the built-in BMS of the SEPLOS was not able to balance these batteries. I have not done a top balance as you usually would do when you put all the cells in parallel and charge them up to 3.6 to make sure they're all the same. I just put them in the case as they came from the boxes. And, well, fair enough. The difference I still had was over 5 ampere hours here from the weakest to the strongest cell. This has now been all fixed. I have used the CKE tester here and my power supply as well to single charge all the battery cells here in the pack. So this took me a couple of hours to do. And I have also organized our balance cables now. So we've got one connector on this side here and the other connector on this side. And we can just connect our active balancer in between for maintenance purposes. And we can balance the whole pack then. I'm not 100% sure what I will do with these cables here. Maybe some Velcro or something. I don't know yet. So I had to shorten some of the balance cables here to get rid of all these spaghettis in here. I wanted to keep the clean and organized design of the whole battery. So yeah, it is still not as nice as before, but we need, believe me, we need the active balancer as a help to balance these batteries, these A-grade batteries. All right, let me cover my battery here and get my desk back. Here on the left hand side you can see certain cells are flashing. This one, for example, this one here occasionally, and this one. I thought this is the balancing function, but for example, this cell here, 3.404, is lower than 3.425, and this one is not flashing. I can also see the voltage difference is going down. I'm not sure if this is because of the balancing the BMS does, or because the voltages are settling down now after I charged all these cells individually. Could be both. We will see this in a second, because we have the charging switch enabled, and I want to recharge the battery now to 57.6 volts, which is 3.6 per cell. The batteries are already charged to 3.6 volts with a 1 amp cutoff. So all these 16 battery cells are absorbed, fully absorbed at 3.6 volts at the moment. Well, without further to do, let's turn on the charger here so we can see 1 amp. And let's see what happens. I really want to give this BMS a chance here, but the balancing, it doesn't look too good. So the state of charge of the battery says 99.9% up here. And it has a total capacity of 135.46 ampere hours. I'm not sure how this is being calculated and why, because I have set 135 ampere hours as a nominal voltage, as a nominal capacity in the settings. There it is, rated capacity, 135. But it claims the battery has 135.46, which I doubt it has. State of health, I'm not sure how it calculates that. Maybe over time we get a certain history while charging and discharging the battery, and then it calculates a state of health of this battery, which would be wonderful. We potentially see this once we fully discharge the battery for the very first time, and then the BMS gets a very good idea what the actual capacity of the whole battery is. Yeah, so we are now at 55.2 volts, which means 3.45 per cell, if they would be 100% balanced. Even recharging them to 3.6 volts with 1 amp cutoff doesn't fully balance the battery pack, obviously. You can see 13, 14 and 16, they have already passed the 3.5 volts, and we get a high voltage alarm for the single cells. But you can also see cell number 1 is only at 3.4 volts. And we've got a 117 millivolt deviation now at 55.5 volts. Voltage is still rising. I have increased the charge current to 2 amps because I don't want to wait that long, which is still very small for these batteries. But now we are at 3.55 almost with certain cells, and more are getting this alarm. See all these orange ones down there? They are over 3.5. And the voltage difference is rising. I have reduced the charge voltage to 56 volts, which is 3.5 per cell, if they would be already balanced. And you can see now we have reached 56 volts and the current is going down, so the batteries don't take any more energy at the moment. And we just need to wait for the other green cells to catch up to 3.5 now. We can now see a second alarm coming up. It's the overall pack voltage, high voltage alarm, which is set to 56 volts. So now we've got a 160 millivolt deviation, and the voltage of the green cells is rising very slowly. And see, the current has even tapered off to 0 now, but we are still charging with 560 milliamps. So around 600-700 milliamps is the cutoff for the SEPLOS BMS to measure anything. Yeah, and potentially we just have to wait now until this is all balanced now. We are still at 160 millivolt deviation, 159, so it's going down very slowly. This could take hours, right? So the BMS is discharging all the orange cells potentially, and then the other ones are catching up because they're still getting 0.5 of an amp. But we can actually try. Let us try to introduce the active balancer now and see if this makes a real difference. This on the other side. So the active balancer is now working. There's the light. And let's see if we can see the overall voltage difference dropping now a little bit faster. Oh, we're already at 149, 148, 147. All right, I mean, this shows it clearly that you probably want an active balancer with the SEPLOS BMS. 140. Okay, I'm just disconnecting the active balancer again. I want to see if there's a difference. Okay, it's disconnected now. I'll leave it off for a moment. 140 is actually rising again. Holy cow. We are charging with 400 milliamps only. The voltage difference is rising again. 142. Okay, this is proof enough for me to introduce this balancer here again. There is actually enough space at the front panel here to put this balancer in there, have all the cables running down this way, and leave the balancer in here and use this run function here with a little switch on the side or internally here just, and then turn on the balancer for maintenance purposes, basically, you know. Twice a year or so. That's what I'm going to do. I just open the case, then connect the balancer and leave it running overnight or for an hour. You can see the voltage is dropping, the voltage difference is dropping now. it is definitely working much better than the internal balancer of the SEPLOS BMS, unfortunately. I was hoping, well, hasn't happened. Okay, I would say give this another half an hour and then I'll be back with some more results. And then we start our full discharge test here with the SEPLOS MASON 6.9. Welcome back on the channel. Okay, so half an hour has passed and we are down to 14 millivolt deviation now with the active balancer connected for half an hour exactly now. So down from 150, 160 millivolt deviation we had at the beginning to only 14. Okay, I want to increase the voltage now to 56.8, which is 3.55, and see if we get a higher deviation there, how good the pack is actually balanced. 3 amps maximum current. We can actually increase that. Okay, let's see. So this is now 3.55 per cell if everything would be balanced. And then the current should go to 0 eventually. But it probably won't, because we've got the internal balancer running as well of the BMS, and this burns off energy, so individual cells will actually lose energy and the power supply just replenish this as we go. So we will always see a few hundred milliamps going into the battery all the time to refill the battery. So we now are at 22, 23 millivolt deviation, but this will go down after a while again. I'm not too bothered about this. Just go a tick higher here on 3.6 volts, which is 57.6 exactly. 57.6. Okay, 7 amps. Total voltage over voltage protection. It has cut off my charger. Okay, I have not paid attention to this one, but that's fine. I think we leave it as it is and start our discharge test now. The battery is 100% full. I mean, 3.6 volts, that is totally fine. I'm going to disconnect the active balancer because we don't want this one to run during our discharge test. And now we cannot further charge our battery because the BMS has decided, or well, the settings have decided 57 volt is enough for the whole pack. Something is not right. Nobody is charging that high usually. I better turn off the charger. Totally fine. It's a safety feature of the BMS, of any BMS. So, well, since I disconnected the active balancer, the deviation actually goes up again. So it looks like the balancer of the SEPLOS BMS is not working or not active at the moment. That's fine. And could you just see this? There is a temperature sensor warning coming up from time to time saying the reading is invalid or something. One of you guys left a message actually under one of my last videos saying that he had an issue with one of the temperature sensors not being soldered correctly to the PCB. I don't know which one it is. I need to have a look in the log files, in the history communication. Now it's the history record or something. You can see all the warnings and errors coming up. Maybe it gives me an indication which sensor it actually is. Okay, I have now prepared our setup. Excuse the setup here on the floor. We've got our shunt in between the battery and our inverter. And I have connected our power supply to the inverter, and then we feed this energy back into our battery number 2 here in the big one. I have zeroed everything out. Time is zeroed out, energy is zeroed out, milliampere hours are zeroed out. So 56.3 volts, everything is fine. And we will do a discharge with 0.2 C, which is 27 amps in this case for this battery, until the BMS shuts down. And I think the BMS will measure the ampere hours as well. I won't leave the computer turned on for 5 hours now. So hopefully the BMS will record all the information for us. Okay, let's start the test. It will be a 5-hour test. And yeah, that's fine. I probably cannot do a 27 amp discharge because the power supply goes only to 21 amps. I don't know. We will have to see what's going on. Okay, this is 10 amps. Increasing to 20, which is just around 20 amps. Well, that cannot be true, right? That cannot be true. 20 amps here is 20 amps on the other side. There would be 100% efficiency of the inverter and the power supply here. So it shows us 30 amps here, so we probably have to go with this one. But then our smart shunt is not right here. Why is this one not correct? Okay, let me do some testing here. Okay, I found the problem. It is, I think, the power supply, the inductive load of the power supply here. I have now connected the Tesla and it works just fine. So the amps showing here, 27, are exactly the same showing here. Well, almost. So this is as close as we can get it. 27 amps. We can do a control measurement here. 28 it shows us. Okay, we need to keep this in mind. So yeah, I think it has something to do with the inductive load on the inverter and the ripple we have on the DC then. So this combination did not work, but we have used the Xia inverter before to charge the vehicle and it was working fine. And now we are discharging with 27 amps here. So hopefully this is all good. All right. I guess see you in 5 hours. Okay guys, we've got a technical problem here with one of the temperature sensors. I think it is this one here. I have already texted SEPLOS in China and they came back to me to measure the resistance of this temperature sensor. But it has just disconnected our test here because we have reached 85 degrees on this sensor. Which is totally nuts, right? This is totally nuts. This is the third one and the fourth one, nothing. Let me disable the temperature safety function and then we continue the test. Damn it! I think this is the function we need to turn off, charging over temperature protection. It is on. The discharge, of course, the discharge. And it has turned on again. All right. We can continue our test. Yeah, thankfully everything stays the same and the car starts charging straight away once the power comes back. The Xia inverter turns on and we are back in business. 27 amps. You can't see anything. 27 amps. Okay. Okay, my friends, it is 10 p.m. and we are almost done with our test. We are down to 5.3% state of charge. I have monitored the whole situation from inside while editing another video because it is so cold tonight. I didn't want to spend too much time in here. So up here we can see the lowest cell voltage is 2.8 volts. The highest one is 2.9. We've got a deviation of 133 millivolt at the moment at 22 amps. So far the battery performed just well. So we are now under 5% and the BMS usually would shut down at 5% state of charge. It would disallow any further discharging, but I have turned this feature off now. I really want to see the BMS shutting down when the cell voltages are getting low to 2.5 volts, which is the case in just a second. But I will show you the result in another video, guys. As always, thank you so much for watching. Thanks for... I'm just kidding. Calm down, calm down. Okay, 2.7 volts. That would be insane to make a cut and a nice cliffhanger now. Yeah, I don't know. The amps are going up and down from 23 to 29. It could be something to do with the DC ripple or something and how they measure the current. But I can see here on the shunt 25 amps. Look at all these alarms here. So one of the temperature sensors seems to be faulty here. I have to measure this later. Okay, we had 4% state of charge. Claims we've got 5 ampere hours left. I doubt we have 5 left. Cell number 13 is the highest. Cell number 9 is the lowest. 44 volts. Under 2.6. So cell number 9 will be our lowest cell in the pack. 43, the fans are slowing down in the inverter now. I can hear it. 2.57. And we will shut down any second. 2.52, 2.51. And shut down. There we go. All right. Oh. Well, my tester is off now as well because the power supply has now shut down. Okay, so here it claims now 0% state of charge, 0 ampere hours left, and the total capacity was 130.87 ampere hours we could pull from this battery here. So this is actually not too bad, right? But let's have a look at the tester and see what result we have there. I need to connect the charger again to put some power on this battery. All right, we are back charging the battery with 10 amps. And we still can see the result here. And let's have a look at the tester down here. What we have. So this is the result. We've got 126 ampere hours pulled with this tester here. And 6.5 kilowatt hours we could pull out of this battery. It is a SEPLOS MASON 6.9. So it's supposed to have 6.9 kilowatt hours. But we could pull 6.5 with this shunt tester here. Within 4 hours and 54 minutes. But we know the current measurement we measured with a clamp meter here directly on the cable was about 1 amp off. So this one showed 1 amp more than the actual shunt tester for some reason. I think this has to do with the DC ripple again and how the shunt tester measures. And if you have 1 amp for 5 hours, this gives you 5 ampere hours. And 127 plus 5 ampere hours. Well, we've got 130.8 ampere hours here. So we are roughly around 130, 132 ampere hours, I would say, of the capacity out of 135 these cells are supposed to have. You can actually go to the warnings here now. Confirm. And it tells you under voltage warning, yes. Capacity warning, yes. So guys, all in all, I must say I'm pretty impressed with this battery actually. I didn't have much hope when I unpacked it and scanned the QR codes for the first time and found out the battery is already 2.5 years old. And I did these 4 capacity tests with random batteries of these 2 boxes, and they were all under spec. But here, well, we are missing 5 ampere hours or 4 ampere hours. So this actually turned out a lot better than I was expecting it. And now after working for 3 days with this BMS software here on the computer, at the beginning, as you know, I wasn't a big fan of this software at all. It looked very messy and not well designed, and I couldn't find the options and parameters and everything. But now after 3 days, you're getting used to this user interface. And the software is actually not too bad. It has some pretty cool features, which I want to show you in a separate video then. For example, it turns off the battery at a certain state of charge, not at a voltage, but at a state of charge. So all in all, it is not as bad as it looked like at the beginning. I still prefer the apps on the mobile phone because it is so much quicker to pull out your mobile phone and connect to one of the BMSs and get your battery life organized. While this one here, it takes a long time to start the computer, start the app, connect to your BMS. It is all different. It is different. Yeah, guys, I guess so far this first test with the SEPLOS MASON 6.9 system here, I think we have covered everything so far. We had a look at the display options of the BMS. We've talked about the balancing, the lack of balancing of the internal BMS, and that you may want to have an external active balancer as well. As well, we have found how to install and organize the software here, how to connect to the BMS. We are just a normal Cat5 cable, LAN cable. And then finally we have done the full capacity test. So I guess this is a good start. And I was really surprised that so many of my viewers have bought this kit already and shared their experience with it under the video. So that's very nice of you. Thank you very much. Yeah, so I guess I will recharge the battery now to 100%, and then I do another probably close to 100 amp discharge test and see how the BMS and the battery performs, all these aluminium bus bars. And we do a bit of an infrared camera thingy as well. See how the power performance test works. And yeah, I must say, so far I like it. Including the big surprise of the capacity we are getting out of it. Okay guys, I guess so far this very, very long video. But there's so much to explore, so much to show, so much to share. I didn't want to cut out too much of that. So if you made it until here, guys, thank you very much for watching. And thanks for all your great support. Thanks for sharing your experience with these devices here. Much appreciate all your information. And until the next video, guys, you stay charged, stay safe, and thanks again for watching. See you then. Bye-bye.